Hey, how's it going there? Welcome to lesson 3.1, part 2. 3.1 says this: I can identify the states of matter and phases present on a heating or cooling curve. Last video we talked about a heating curve. This video we're going to be breaking down a cooling curve. So when I look at a cooling curve, I actually think of a heating curve because a cooling curve is simply a heating curve in reverse. Notice that the features are very similar. We have these upwards or downward sloping lines. We have these flat parts, and then it really truly looks like the same thing in reverse. So here's what we want to write at the top on our cooling curve. So we're going to label here, this is a cooling curve, okay? And in parentheses, we're going to say heating curve in reverse. Instead of gaining particle energy and getting hotter, the particles are actually losing energy and getting slower. Let's go ahead and take our highlighter and define the downward sloping sections. So here's one right here. Here's one right here. And then here's one right here. These yellow sections are temperature changes. If you want to be specific, they're decreases in temp. And what you want to remember is for temperature changes, it is always going to be a single phase of matter. So let's go ahead, let's take our highlighter, and let's highlight this so we see that it corresponds to the declines in the graph. Now let's take our green highlighter and let's highlight the flats. And let's write about these here on the side now. So we'll call this a flat. And remember, in a flat section, there are two states of matter. Let's grab the green highlighter and highlight this so we know that those colors correspond also. Let's now label our critical temperatures on the graph and really talk about what's going on in each section. So remember, steam boils or condenses at 100 degrees Celsius. So we'll even label freeze, or I'm sorry, boil / condense. I know that room temp is going to be somewhere in here. And remember, room temp is around 25 degrees Celsius. And then here's going to be our last really critical area. Water freezes or melts at 0 degrees Celsius. So here we'll write down freeze / melt. So notice, because this is a cooling curve, we're not going to pick the words boil or melt. What we're going to pick is condense and freeze on the way down. Let's take a moment now to kind of narrate the situation and talk about the graphics that we see. So first here we start off as a single stage of matter. We have a gas called steam. Then it tells us we get this flat section of temperature. It halts, it stops for a little bit to change. We go from a steam to a liquid. That's what the word condensed means. Gas to liquid. Then later, we have a pot of liquid, we could say, or just a portion of liquid, cooling down or changing temp again. Then we get to another plateau, this flat section where the temperature stops for a while. And what's happening here is the water is going from a liquid to a solid. This is what would happen in your freezer. And then as soon as we become a full solid, in this last section, we have a single phase again. So just to kind of recap, one phase of matter, then we switch to two. We go back to one, we switch to two, we go back to one. Let's go ahead, let's write this out so we can remember this. We'll go ahead now and add some alphabetical points and talk about specific sections. So we'll label this beginning A, this point will be B, we'll label this point C, this point D, this point here is going to be E, and then this point here is going to be F. Okay, so next to the graphics, we're going to write down what's going on. And we'll erase a little bit to make sure we got some room for ourselves. So from A to B, we have a gas, and we call this gas steam. So now from B to C, we have two phases of matter. We have not only a gas, but a liquid at the same time. And again, the word we used was condense. All right, so next to the water pan here. Here we'll call this C to D. This is just liquid. So a single phase again. And then here we go. We'll call this section D to E. In this section, we have two phases of matter again. We have now a liquid plus a solid. And remember that solid is called ice. And then notice that we call this, again, freezing. And then here's our last section, E to F. This is just a solid, and again, this is called ice. So if there's one thing I could really leave you with here today, is kind of like a conclusion or a synopsis. Here's what we're going to write, and this definitely you want to have in your notebook. So here are some key points that you really need to know. Okay, so we're going to have two of them. So here's what key point number one is going to say. If there's an incline or decline in a heating or cooling curve, and you'll have to decide which one's which. What that means is that in that section, there is one state of matter. And remember, it's either going to be gas, liquid, or solid, but never anything combined, okay? And then here's going to be your key point number two. When you see a flat, that's what I call them, a flat in the graph. What this means is that there are two states of matter present. We call this a phase change. So the combinations you'll have here will either always be solid plus liquid or liquid plus gas, never pretty much solid and gas together. And that's kind of what we have to really summarize out of this lesson. Anything solid plus liquid will happen at 0 degrees Celsius, and anything liquid plus gas will happen at 100 degrees Celsius. Remember, 0, we said freeze/melt, and then 100, we said boil/condense. All right, and that should cap off our lesson. Please review your notes. Rewind as needed. And as always, have a great day. Thank you.